everybody. Thank you for joining us for this new series of Geotalks about alumni of the School of Geosciences. And I'm very happy and proud to show you or to introduce you to Professor Richard Viljoen, that is an alumni from the School of Geosciences. He did from the undergraduate up to the master and PhD here in the School of Geosciences, as maybe some of you have done. So it's like a role model for us. During his master degree, he actually worked on the... Hello, Jill. Would you like to do the introduction? Shall I continue?
Sorry, I'm late, everybody.
No problem, we just started. And please come in. And during the master degree, he studied the mineralogy of the goldfields of the Witwatersrand gold. And I trust that at that time, the gold mine looked quite differently than now, compared to now. And then during this PhD, he studied the Barberton Greenstone Belt. And during his studies, together with his brother Maurice, they found new rocks. They found rocks that nobody has ever described them before. They were high temperature rocks, high magnesium. Now we call them chromatites, but at that time there was no name for it. Actually, Richard and Maurice are the one they gave the name as the rocks had been exposed, and they found the mapping along the Chromati River. So this is why the rocks are there. And in 2019, we have a 50th anniversary of this discovery. So it was a very special event. Then he worked in the industry, has more than 30 years in experience working for JCI, and then the Goldfields, where he works at a consulting company in many exploration and mining in Africa, but not only in Africa, also in Asia, in Turkey, and now in India, Ecuador. So actually, you can ask any kind of question. I believe that Richard has experience on any kind of gold deposit on the planet. He is a recipient of a number of prestigious awards, including the Honors Award of the GSSA, the Lindgren Award of the SEG in America, and the Draper Medal, that is the highest award of the Geological Society of South Africa. And the latest two awards were together with his brother Maurice. And he was president of the GSSA and in two different occasions, and he's a fellow also of the South African Institute of Mining and Metallurgy, the Royal Society of South Africa, Society of Economic Geology, and the Geological Society in India. So I'm looking forward to hear what he has to say about the story of the Witwatersrand Goldfield. And thank you very much for joining us today, Richard. Thank you.
Yeah, thanks very much, Linda, for the introduction. I can just say it's a pleasure being back at my alma mater and to see all these young geology students. What I'll talk about today is the Witwatersrand goldfield. And the discovery of this goldfield was, I wonder if there are lights here at all. Yes.
We just had a lights on.
I'll just need it to start with, and then we can turn it off. So, yeah, the discovery of the Witwatersrand goldfield was one of the most important events in the history of South Africa, because never before and never since have such a phenomenal amount of gold been found in a single deposit or single gold field. And 1/3 of the gold ever produced on the planet, in fact, has come from the Witwatersrand. And we are sitting right here on Witwatersrand strata, incidentally. We'll talk about that later. The story of the discovery and the development of the gold field with the parallel growth of Johannesburg to become the largest city in South Africa and the financial hub of the African continent is a very compelling one. While the role played by the University of the Witwatersrand in the development of the gold field from the origin of Wits, as firstly South African School of Mines in 1922 to become the Witwatersrand University. And this is an important part of the story, because Wits has supplied well-qualified engineers, scientists, and other professionals, geologists, many, over the years, and this has ensured that the exploitation of the Witwatersrand Goldfield has been in good hands. So Wits has played a very dominant role in the development of this goldfield. So only bits and pieces of the story of gold can be told in one presentation, and I've been fortunate to have been able to weave these together from a number of sources, including the photographs, tour booklets, and notes of the late Professor Maurice Viljoen, whose huge contribution is greatly acknowledged. And I'd also like to thank my wife, Miranda, for her considerable help in putting all of this stuff together and compiling today's presentation. So let's get started with what we've got. A view of Johannesburg, sitting on the Witwatersrand Plateau. So I think important just to understand the geological setting, because that's really important from the Witwatersrand point of view. Basically, the Witwatersrand strata outcrop in this brown area here, which is known as the Witwatersrand Plateau. And you can see the yellow here on the right is the geology, with the position, is it there? Thank you. With the position of the gold-bearing reefs and the dotted red line over here and over here. And you'll notice that the blue material, which is the dolomite, actually covers the Witwatersrand strata here in the west. And we'll explain just now the importance of looking through the dolomite in order to trace the Witwatersrand strata. Now, to the north over here, this area with this dendritic pattern are the rivers of the Crocodile and the Yukskate. And you'll notice a whole number of other rivers draining off this Witwatersrand plateau to the north. All those rivers join up, and they flow north into the Hartbeespoort Dam, and from there further north, eventually into Limpopo. The Limpopo flows into the Indian Ocean, and so all these rivers flow into the Indian Ocean eventually. Whereas just to the south of the plateau, you'll notice other streams that are flowing in this direction through here, and over here, they flow south, eventually linking up with the Vaal Orange system and eventually flowing into the Atlantic Ocean. So in other words, this Witwatersrand plateau is a watershed, right, running right the way through here. But anyhow, getting onto the area to the north, this area of dendritic pattern of drainage is underlain by granite and greenstone. The greenstone is indicated here in the purple color and the granite in pink. And incidentally, the man who mapped this, Professor Anhauser, is sitting here, right here. So anything you need to know about the Johannesburg Granite Dome, he's the man. So the Johannesburg Granite Dome, and then to the north, you'll find these very distinct ridges of valleys and hills known as the Bankenveld, consisting of ranges of the Tyndall Hill, the Duspoort and the Magaliesberg range here to the north. So they indicated there. There's the geology, and to the north of that are rocks of the Bushveld complex. I should have mentioned that just to the south of the Witwatersrand plateau are the Tiprefiersberg, and those are lavas that actually overlie the Witwatersrand strata. So you need to look at the section to see the original disposition was such where you get the Witwatersrand strata, the overlying volcanics of the Finnersdorp lavas, and then the overlying dolomites here, and then the Pretoria is the brown, and then right at the top is the Bushveld. So what happened then was that this basement granite, uplifted by tectonic forces, by thrusting and by upward pressure from plumes from below, and tilted the rocks. So if that hadn't have happened, we never have got this exposure of the Witwatersrand strata on surface. So that is really important. not only from the uplift point of view, but also from other points of view as well, which I'll explain later. So that setting is quite important. So what happened with the discovery of gold? That's just a view of the edge of the plateau. That's the hill at Northcliffe. And there's Johannesburg sitting on the Witwatersrand plateau. And the discovery of gold is an interesting one. And then very briefly, it started in 1853, where a chap by the name of Pieter Jacob Marais, who had been one of the 49ers. In other words, he'd been looking for gold, prospecting for gold in California in 1849, but he wasn't very lucky there. So he came back to South Africa and tried his luck, and he found gold in both the Yukskay and Crocodile rivers, not far from here, just to the north, and from another spot now in Sandton on the Braamfontein Spruit called Panner's Lane. And in fact, there's a blue plaque there commemorating that as a site where gold was panned, also in the early days. Following Pieter Marais, we had the finding of the Kromdraai Goldfield, which is just flanks the dome here to the west. And then after that, the Blaubank Field, 74, 78, 70, around about there. And then what was called the North Slope Rand Field over here, which is the yellow, and that was discovered, a quartz reef was discovered by the Struben brothers, and they mined a quartz vein. Now, the important thing is that all the gold that I've described occurs in quartz veins. And that goes for the gold that was found in California, the gold that was found in Bendigo and Ballarat in Australia. The gold that was found in all these areas where gold rushes took place was in quartz veins. So people were searching for quartz veins. And indeed, quartz veins had been mined. In fact, something like 6,000 recordings of ancient workings before any settlement in Zimbabwe. 6,000 ancient workings on quartz veins for gold. And so these quartz veins were very important. But interestingly enough, there was not one single ancient working on the Witwatersrand. So one might ask why. The reason now will emerge, and that is that the gold occurs in conglomerates, pebble beds. Now, these conglomerates were actually sampled by the Struben brothers in 1884 near Krugersdorp, and they found small amounts of gold, but insufficient to warrant much attention. So they carried on mining their Confidence Reef in quartz vein over here. However, in 1886, guys had sampled a similar conglomerate, and they'd taken the conglomerate to the Struben's plant at present-day Struben's Valley near Kloofendal, where they crushed that conglomerate, and they found huge amounts of gold. So all of a sudden, the search was on. What the heck is going on here? And they had, in fact, discovered this vast gold field. And so that was the beginning. So it took a while. And then that was then called the South Slope Field over here, Rand Field, in 1886, gold in Pebble Layers. That is just an idea of the Strubens working at Kloofendal, the Confidence Reef. That there is the plant with the Struben brothers, Harry and Fred, and there is the quartz veining that occurs in the area, and that quartz veining contains gold. But it's not all that extensive. So this is what these pebble layers look like. You can see here the discovery site where that gold sample had come from. And you can see the pebbles here layered, and you can see a little discontinuity and then another layer. That's called the main reef, and this is called the main reef leader. Two of the most important gold bearing reefs in the area. And you can see those if you're lucky, now at Langlaagte, which is the discovery site. Oops. No, I don't know what happened there. Sorry. Okay, so all we know of the people who discovered that gold at Langlaagte was Walker, and his grave here is to be seen in Krugersdorp, where he says he discovered the main reef. So, but that's all about we know about the guy. We don't know too much more about him. So, from that discovery, the new goldfield started developing, and the guy in charge was a chap by the name of Pereira, and he in fact established a little gold mine, started mining, and it was called Ferreira's Camp at that stage. And you can actually see Ferreira's stope where he mined at below the Standard Bank building in downtown Johannesburg. And that area that has been mined out over there is actually the position of where the main reef leader was. The main reef is still to be seen. In this area, the main reef was a bit thin. As you can see, it's a thin band of conglomerate, so it wasn't really mined extensively there. But it's a very historical place, and if you want, and it gives a very good idea of all the events that I've been talking about as well. And people came from all over the show. There was no railway, there was no road, there was no nothing to come to Johannesburg to try their luck at this new goldfield. So that was the mode of transport, and people came from all over the place, all over the world. And the gold reef soon became known as Banket, and it was named after a Dutch confection of almonds embedded in brownish sugar. And you can see that's what it looks like. So it was called Banketje or Banket. And that name was used extensively in all the early literature. And I'm not sure if it's used much anymore. But that was the origin. And then the origin of the name Witwatersrand comes from the white ridge here of Orange Grove quartzite, which forms the basal layer of the Witwatersrand sequence, and white water flowing over white rock. So we're not quite sure whether it's the white water over white rock or the other way around. In any event, it was white, so it's called Witwatersrand. Other people say it was the actual position of the watershed. So it's up to debate. Anyhow, I like the idea of the white water flowing over white rock. Witwatersrand. So the early development took place along the outcrop of the reef, which is shown in this purple line, and you can see the little stars. The Robinson Deep, Ferreira Gold Mine, Wemmer, Jubilee, and Meyer and Charlton, and Village Main, all developed on outcrop with Ferreira's stope over there. And then the position of the triangle that you see there, it was called Reinke's Laagte, and that's where Johannesburg was actually laid out between the farms Braamfontein, Doornfontein, and Turfontein to the south. So a bit of Uitval front, as they called it. Anyhow, that's where things started developing. And then the area had to be surveyed, and there were quite a number of these surveyors, one of which was this chap, Pritchard. He was also a prospector, but he laid out the very first streets in what is now downtown Johannesburg. And these are the early workings. And as you can see, they were narrow conglomerate reefs, and they were mined at quite a steep angle over there, and everything was going fine. Johannesburg was a boom town. And that was fine. But eventually it got to 30 meters below the surface, and the ore was no longer oxidized. It had now become a reducting situation. So the gold now was associated with pyrite, locked up in pyrite, and they could not extract the gold. So all of a sudden, this huge bonanza gold field looked as though it was dying. And people started leaving Johannesburg, became almost a ghost town because they couldn't extract the gold below 30 meters below the surface. So that was the problem. Oxidized ore, you can see the banketcha, and then the unoxidized material, the gray material below. But we were lucky in that two chemists came to the rescue, MacArthur and Forrest, and they had been experimenting with cyanide, and they could prove or show that the cyanide would dissolve and you could get the gold extracted from that banket ore, or from the unoxidized ore. So that, of course, changed everything. At the same time, Joseph Curtis, who was the first professional geologist on the goldfield, drilled the first borehole, and that borehole intersected the main reef at a depth of about nearly 1,000 meters. So it was a pretty useful borehole. And what it showed was that there were still good values at that depth. That meant that there was the downward extent of these gold-bearing reefs, highly important. And subsequent boreholes were drilled by other guys. The Turf Club borehole also intersected good values, and the Bezuidenville borehole as well. So those three boreholes were the key to the future. And then at the same time, one of the first mining engineers, Henning Jennings, predicted the gold reefs would extend along strike. So now they found that was the case. So people had worked right the way along the strike, and now they were working down dip. So all of a sudden, it became a huge project, a huge gold field was developing. So the guy who had foresight to get into cyanide quickly was this chap, Sir Joseph Benjamin Robinson. And you can see the chlorination plant at the top that he had. So they're using chlorination to begin with to extract the gold, because that's what was used in Australia and California, etc. But within a month or two, or maybe a bit longer, he converted all those chlorination plants into cyanide vats to extract the gold at depth. So he was a leader in the use of cyanide. And that's just a map that shows the position. That's from Henning Jennings. Shows the position of surface workings of mines that had been laid out at that time, the white blocks. And then essentially there were two companies. There was what is now Rand Mines and Goldfields of South Africa. And they took up then what they called the deeps. In other words, people had pegged claims right along the outcrop. But as soon as they realized the gold was extending to depth, this whole area, that area was taken out there, the dots by Rand Mines, and the other area by Goldfield. So they tied up the deeps, as they were called. And that's a whole different story. And Johannesburg started booming, and there's the old Market Square on Commissioner Street to the right. And then there was only horse-drawn traffic at that time. And here you can see quite an interesting market morning in Johannesburg. And you can see it. You can see a tram here, drawn by a horse or a mule, and on a railway line. It's called the Rand Tram. And of course, speculators galore, prospectors galore, and the startup of the first stock exchange. And the whole concept of between the chains, and the between the chains was the area where guys would go and discuss financial deals, and from that they would go and buy shares in the mining companies from the stock exchange. So that was a very important part of the setup. And then of course they started building these major infrastructure in the form of headgears, the world's highest headgear. It was over 100 meters, I believe, and must have cost an absolute fortune at that time, but that's what they did. And there is what they call a tailings wheel to distribute the tailings from the crushing of the ore. Huge infrastructure development. And of course, the stamp batteries, which are used to crush the ore as well. And labor, mine labor, they're highly important. And you can see it was a very difficult mining proposition because you were mining a narrow reef at depths. Now they were getting down to hundreds of meters below the surface and even further, and they needed labor badly. And that's when the whole question of mine labor arose. And many of the people at that time were drawn from Mozambique, and they came across the border at Pafuri in the Limpopo area, and they walked or came by donkey cart or whatever, and their first stop was at this point over here, and that in fact was called Baobab Hill, which you can see, which is now a heritage site. So that then they eventually arrived on the reef, and they were accommodated in compounds. And these are the mine compounds that developed at the time. Thousands of laborers lived in these compounds, unisex compounds, and that in a way was the start of the whole question of separate living and separate development, where the black miners from other countries, some from Lesotho, came and settled in these compounds, whereas the white miners settled in suburbs that were developing in the city of Johannesburg. So all that infrastructure and the cost of mining and the cost of labor and the cost of building headgears required money. So financing was important, and that was the beginning of the entrepreneurs. And they developed what are called the mining houses in South Africa, and had the money to develop these deep level mines that required money. And the first one to form was by Rhodes and Rudd, Goldfields. And that was registered in 1887, 1 year after the discovery of gold. And soon after came this chap, Barney Benato, in 1888. And he actually couldn't find any claims. All the claims had been taken up. Anyhow, he developed a company called JCI. That's the JCI house, which is now a historical building in downtown Johannesburg. And that's the new JCI house over here. Anyhow, Barney Benato was quite a shrewd entrepreneur. So what he did was, in the developing city of Johannesburg, needed water. So he then got the rights to water and started the waterworks company. And the water was some of it from the Russell Stream, quite a bit of it, in fact. There's the Russell Stream running through here. This is long before the Vaal Dam and the Rand Water. And the other was the Natalspruit over here. So he sold water and made a fortune out of selling water. He also got involved in developing property, and he took up what's called the Houghton Estate. And the Houghton Estate is over there, and it occurs on top of the plateau that's called Upper Houghton, and below the plateau over here called Lower Houghton. And those are still very important suburbs in Johannesburg, one of the early suburbs that broke away from this triangular story over here. Here's my, oops, sorry. So what I want you to look at are just a couple of important things. Firstly, the position of that main reef outcrop over there, the development of Johannesburg, the position of this thing here, which is called the Contorted Bed. In fact, we're sitting here at Wits, virtually on the Contorted Bed. And if you go to Jan Smuts Avenue, you'll see the Contorted Bed, if you dare get out of your car on that very busy road. It's right on the bend, just outside Wits. So that's Contorted Bed. And then to the north is the is the edge of the plateau, the Orange Grove quartzite that I talked about. So just remember those three because they're important kind of markers. So Albani Bonato then eventually managed to get some claims and developed JCI as a major mining company. Other guys were Herman Eckstein and Lionel Phillips, who developed the Corner House. That then became Rand Mines, so another mining house developed. And these guys are all in competition with each other. There's still a remnant of one of the old shafts near Wemapan, south of Johannesburg, still to be seen. And then the guys who had made their money, these landlords, decided they didn't want to live in that dusty mining environment. So they all moved to the Orange Grove Quartzite Ridge at the edge of the plateau over here and built their houses on this plateau edge. The reason was they were away from the dust and they had a good view of the Magaliesberg. So, and they could, and the Orange Grove Quartzite was very good building stone. So these are some of the landlord houses that they built at that time. That was Hohenheim of Lionel and Florence Phillips. It's now, it later became the site or became the Johannesburg General Hospital. And then Northwoods, which is still in very good nick. It was owned eventually by General Mining, George Albu, and firstly by Dale Lace and his very socialite wife, Josie, over there. And you can visit that place, you can see the whole story. And then Villa Arcadia, Lionel Phillips and Florence Phillips. That you can still see, that house is still there. And then the Sunnyside Park Hotel, which was the house of Hennon Jennings, the mining engineer, and eventually became the house of Lord Alfred Milner, the British High Commissioner, after the Boer War. And that was the architect, Herbert Baker, and that was his house, the Stone House. Now, they also needed education. So that's where these schools started developing. And a whole bunch of these schools developed in this area. We get King Edward School over here, Jeppe High School over here, Bonato Park Girls School, St. John's, Rodine, Parktown Convent, Parktown Boys High over here. So those were known as the Milner schools because Milner wanted schools to be built in the English tradition. So that's why they were called the Milner schools. Also, you'll notice that that was the start as well of the University of the Witwatersrand. So they needed to educate people both at school level and at a university level. So those are just some of the buildings there, Bonato Park, Rodine, St. John's, and Wits that you know very well. Now, one of the things, once this had started, we got various engineers, scientists, and so on from Wits and other institutions. The early ones had come from the United States, the early mining engineers. Later ones were all trained at Wits, or most of them were trained at Wits. The question became, can we trace these gold-bearing reefs? And the key at that time to tracing the reefs was the use of magnetics. And so here you can see what's called the contorted bed, which I pointed out on the map earlier, consisting of hematite and magnetite, black minerals over here, and the silica minerals, chert and jasper, a beautifully banded rock, but it's magnetic. And the idea was, because of that magnetic property, you should be able to detect it below surface. And that's exactly what happened. And that was the introduction of magnetics. That's why it's called the contorted bed. You can see that. And the magnetic markers, you can see some of them. That's the botanical gardens near Rödepoort. These are the shales in between the white quartzites You can see further marker beds over there. And most of those are magnetic, but the contorted bed in particular was very magnetic. Now, the people who had these ideas were Reinecke, who at that time was the Goldfield's consultant geologist. Then Carlton Jones, who was the Goldfield's mining engineer, and Kramen, who was a geophysicist, who had just brought out the use of geophysics. So by using geophysics, the idea was to trace the reefs below cover. And just to put you in perspective again, what we're talking about is the Johannesburg Plateau, the reefs outcropping here very nicely, outcropping in the Randfontein area, but then disappearing under the dolomite. So in order to study that, this is the pattern that Kramen produced. All the dotted white lines here are magnetic marker beds, indicating the position of the magnetic beds on surface here, with the orange is all surface outcrop. And from that, you could interpolate the position of where the reef should be. There's the reef, there are the magnetic markers. So here are the magnetic markers, the reef should be there. So there, and the reef should be there. So the gray there are the options taken out by Goldfields. So they acquired a complete Goldfield, probably one of the biggest ever, just from this geophysical information. And then, of course, they drilled boreholes and they proved the reef was there, and the rest is history, development of the West Wits Goldfield. The other thing of interest is that in the Central Rand area, the topmost conglomerate of the Witwatersrand sequence, before it's overlain by the Ventersdorp lava, is called the Mondior or Alsberg conglomerate, and there you can see it outcropping with typical sugar bush vegetation because of the acid soil. And then down here to the south are the lavas of the Ventersdorp, where you get totally different vegetation because of the richer soil over there. So those lavas overlie these beds over here. But in this area, these reefs are not economic. The Mondiors are not economic. There's very little gold in them. So they were never looked at in any seriousness. What am I doing here? No, sorry, I can't see these things, sorry. Okay, so the Ventersdorp lava poured out, and as you can see, artist impression covered the pebble layers like that. And these algal mats probably lived out here somewhere, but that's the kind of scenario that developed at that time. That's what the Ventersdorp lava looks like in part, full of these gas cavities, very distinctive. But in the Goldfield to the west that have been discovered, the lavas directly overlie a conglomerate, and it's a totally new reef called the Ventersdorp Contact Reef. So you can see the white pebbles here of the Ventersdorp Contact Reef, very, very rich in gold. And these are actually pillows from overlying lava, beautifully developed pillows here. Now, in other words, this is now a completely new reef that doesn't exist in the Central Rand. So they discovered a new reef, the Ventersdorp Contact Reef, as it was called. And they also discovered another reef that doesn't occur in the Central Rand called the Carbon Leader. So it's a carbon-rich reef, rich in gold, okay. So the present position then is the goldfields of the Central Rand, the West Rand here, and then the West Wits line here, 5B and 5A, and the East Rand had also been developed. But then by subsequent use, mainly of geophysics and drilling, Klerksdorp was developed. The Welkom Goldfield was developed over here with the use of magnetics and gravity. And then the Evander Goldfield also using geophysics and drilling. So within a couple of decades, this whole goldfield had been exposed by drilling and geophysics. So all of a sudden we realized we had a giant here. So what happened next though was that the reefs were getting deeper, and on the West Wits line in particular, so people were going down to over 2 kilometers at that time. And so these are some of the conditions at depth over here, problems of rock bursts and so on. So one had to adapt to mine at depth. The results of rock burst, and also the way that rocks are supported by the presence of backfilling the slimes into the stopes. And then, of course, cooling. So these are huge refrigeration plants on many of those mines, making ice, and the high pressure cold water jet is then shot down and shot into the workings, into the atmosphere for cleaning the stope. And that cools the atmosphere where the rock temperature is probably over 60 degrees. So all of these innovations came about from mining engineers and others and geophysicists, and many of them were trained at Wits. So Wits had a very, very important role to play here, and particularly in an organization called the Chamber of Mines Research Laboratory, which did research on all these aspects. So mining engineers, geologists, metallurgists were all involved in these kind of projects, particularly aimed at mining at depth. And I think Ray Durham is here, he's one of them, working on seismics at depth to understand the structure of the reef at depth. So the guy who had the money and chutzpah to develop deep level mining was Ernest Oppenheimer. And this Western Deep Levels gold mine was at that time below 2,280 meters. They're now mining at 4 kilometers below the surface. So you've got to really have guts to do that, and you need money as well. Anyhow, Oppenheimer was a leader in pushing for deep level mining. The other thing that arose at that time was the idea of where the heck did all this gold come from? And one of the early ideas was presented by this chap, Leopold Reinecker, and he discovered one goes from the regional to the detailed, and on the operating mines, they produced plans of gold distribution. And these plans were all meticulously drawn up from the sampling that had been done by the samplers and ready for mining. And they showed, and they gave rise to plans which gave, for example, the reef width times the gold value, which gives you gold content and other parameters. And this produced what they call spotted dog plans. And Reinecker looked at the spotted dog plans, and he found that there were definite trends to the spotted dog. And what he found was that these are the trends that he found here in the Central Rand, over here and over here and over here, and beautiful trends in the East Rand over here. And these were called pay shoots. So the whole concept of pay shoots came in, but you can see that his idea was that the gold had been transported by water and deposited in these pay shoots by water. So most of the geologists and mining geologists on the Witwatersrand stuck by this method of defining where the pay shoots were by interpreting the gold content by multiplying the gold grade and the thickness of the reef. And it worked pretty well. So the ideas that developed were firstly that gold was detrital. And some of the evidence was given here, besides the pay shoot patterns, by this beautiful sample here, which shows on the top photo gold in 4 sets on cross beds. And that, in fact, was a photograph by Laurie Minter and Hartwig Schimmel. And they both produced these kind of things and observations, which suggested very strongly that the gold was of sedimentary origin. But other people then came along and said, no, but look at this here. You're getting a quartz vein full of gold cutting right through the conglomerate. Now, that means the gold must have come in later. So now what's happening here? And this has led to major debates over the years. And we'll talk about it a little bit later. There's some of the beautiful samples here at Wits have over here. Gillian made it available so we could have a look at this stuff. Beautiful samples of gold, visible gold. So that clearly looks like later or hydrothermal type gold. And a beautiful crystal. You'll notice that all this gold is on quartz veining kind of material. That's also in the Wits collection. And also gold was found to be concentrated at times, as I showed earlier, with carbon. Particularly at the base of certain reefs and so on. So that was another kind of concentrating mechanism of gold, carbon. And this is also a section through one of those carbon-rich areas. The carbon, you can see a circular spindle here of carbon with a uraninite, a broken up uraninite grain in the center over here. This is per kind permission of Gillian again. She's working on these things. So there's an affinity between the carbon and the uraninite, because that's the other element of importance in the Witwatersrand, the uraninite. And then you can see the gold over here. So there's an affinity with gold and uraninite. So that's another mechanism. So what's happening here? So all of these things have been mulled over for many years. There's some of this oil development in the Wits. That's another story developing. Now, in about the first person at Wits really to get involved to some extent with the gold was actually the first principal of the South African School of Mines, which became Wits in 1922, and that was Goldfield. And then one of the first professors at Wits was Professor Young. And Professor Young did major studies on the Witwatersrand banket, particularly the mineralogy, and he produced many papers and came up with many ideas on the mineralogy. But I think that the whole thing kind of took flight, if you like, in 1997, when Professor Pretorius was appointed as the head of the economic geology research unit here at Wits. And that research unit then started doing research on gold, both in the greenstone belts of the basement and also, but particularly the Witwatersrand. And this had come across from the Chamber of Mines, which represented the mining houses. And the mining houses said, look, we want to know where the gold comes from, how do we find more gold, etc. So we need all these questions answered. So the Economic Geology Research Unit was formed to study just this kind of thing. And from 1957 onwards, a huge number of papers and research projects were carried out and are still being carried out on aspects of the Witwatersrand. But it was kick-started by this Professor Pretorius. And so the basic tenet is that basically the unoxidized banket is pyritic, so it must have been formed in an anoxic atmosphere 2.85 million years ago. So it was very old and Archean, late Archean in age, actually. Then other evidence came to light from the mining, and a lot of studies were done on the channels that you find in the gold. And here you can see very beautifully, there's a footwall of a channel. You can see the concave footwall over here, resting on a khaki colored footwall. And then you can see cross-bedded material here within the channel. There's the top of the channel over here. And studies were then done on the direction of sediment transport by measuring the cross-bedding troughs. And from this, major deductions were made. And when one compared these to the spotted dog plans, all of a sudden, the whole thing started making a lot of sense from a sedimentary point of view, and also from a point of view of helping the miners define more accurately where the mining blocks were going to be. So all of these innovations came about by research, or many of them by research done here at Wits, at the Economic Geology Research Unit, at the Chamber of Mines Research Laboratory, who studied the rock mechanics and more mining engineering side of things, and also the government mining metallurgical laboratory, which is now Mintech, who studied the mineralogy of the Witwatersrand. So all of these things sort of started coming together now, a major research on the Wits, with the kind of model that is now developed with the lowermost Orange Grove quartzite, the Contorted Bed, and other magnetic markers, the main reef group, the Kimberley reefs, the Mondial reefs, also the bird reefs, with the dendritic deltaic kind of pattern, shallow sea over here. That's kind of the model that seemed to be developing. And so what we get are a series of these reef bands dipping to the south, the main reef group, and the birds and the Kimberleys and the Mondials and the Finnersdorp Brava. So that's a story that has emerged. And there is the kind of model, artist's impression, Maggie Newman's impression. There you can see channels that are formed in this kind of fluvial deltaic environment, carbon leader forming from these algal biomats, and more continuous reefs forming more in the offshore kind of situation. So those are kind of the models that people work on now in making predictions as to gold distribution. Example of that was done here at Wits in the Center for Applied Mining and Exploration Geology by putting together all the information in the central rand on the main reef leader, and what emerged was an amazing pattern which actually sort of fitted beautifully with old Reineker's pay chutes. There's the main pay chute coming down there in the center over there, with subsidiary pay chutes off to the side, another pay chute there, and another pay chute over there. From that, one was able to say, right, the mined out areas has been the green, okay, from the surface, and they'd stopped mining at about 2,900 meter odd. So what we then did was calculate the amount of ore left and divided into the stuff above and below, and there's just a huge ore resource left below Johannesburg, 35,000 tons there of gold. So you can use these methods to predict. We had one or two borehole intersections here, which gave us a clue as well. So you have to use these models in order to understand the distribution and the amount and where the gold is. So that is the example of the Central Rand Goldfield. So anyone who's got a couple of billion rand can go and sink a shaft and do something, because the problem is that to get to those depths, you need about 3 shaft systems. The primary shaft over here, you need a secondary shaft, you need a tertiary shaft, each one taking you down about 1,000 meters or so, and then eventually you reach your thing, and then you have a decline down here. This, in fact, is about 3 kilometers, I think. So that's where you're still getting very good gold values, 3 kilometers below the surface. So anyone who's interested, you can start a mine there, but you've got to get there. So now that's where the future comes in, the use of robotics and all sorts of things, which we talk about now. But you need to know where the gold is to start with. And that was the Crown Mines, which is one of the top mines ever in central Johannesburg area. Other modeling of ore shoots on the Kimberley reefs here in the Roodepoort area. There's a huge ore resource below Gold Reef City. There it is. You can actually see the mined out area are these gray areas here. And these are the projected ore shoots from all those sedimentary and value data that I mentioned. And then here's another example. This is the Cook section of the Randfontein Estates on the Elsberg reefs, where you can see beautifully distributary channels of these gold-bearing reefs. This is now from the historical data. And you can also then see that there's not too much more potential in that particular reef. There's a chute down here you could probably follow, and there's probably some extension down here, but essentially you're running out away from the shore area or wherever the gold came from. Actually came from the Panflakte fault, which is over here. So by reconstructing these environments, you can guide mining and where to drill and etc. So it's highly important to understand these things in the Witwatersrand. So just a brief idea now that the gold, as we saw, has been mobilized into secondary quartz veins, which invade the reefs and other areas. It looks as though there are two heat sources. The one heat source would be the bushveld complex. So in other words, the heat produced by the bushveld and its satellite dikes and sills might have been responsible for some of the mobilization of the gold, particularly in the northern part of the basin. And then in the central part of the basin, you get this huge meteorite impact scar over here, and that for sure could have been responsible for some of the movement of the gold. There, in fact, you can see beautifully the scar of this meteorite impact, a beautiful dome, which is up-domed the Witwatersrand strata over here. And you can see that there was even an old goldfield here, the Ventus-Kruin goldfield, but the values were fairly low and it was disbanded. However, the heat caused by the meteorite might have been responsible for some of the mobilization. And in fact, the melt rock called pseudotaculite has been found in some of the mines of the West Wits goldfield. So that seems to be quite a far away from the meteorite impact, but it was a big meteorite. So the various ideas on what mobilized that gold to give you the impression that it's hydrothermal. And that's just a schematic thing of the theatre fort with the fracturing and so on, and the present situation over here with part of the western part of the Johannesburg dome over here. So we end up with the world's largest gold producer for 100 years till 2006. That is now diminished. We now number 6 gold producer in the world, but we still have twice the amount of gold in the world's second largest gold field, still available in the Witwatersrand. But a large proportion of that will be at depth. So the trick will be to mine these reefs at depth. The other important thing is, and things that people bring up all the time, is the problem of pollution from gold mining activities. And one of the problems in the earlier days was the problem of dust. And that's in the dumps in the Meadowlands area, where you can see that dust just blowing across and contaminating huge areas. The Chamber of Mines also did a lot of research on this, and they developed the vegetation of dumps and other means. So that dust problem is still there in some areas in active dumps, but has largely disappeared. So the other one was the acid mine drainage. So what happens is that the pyrite that's left behind in the dump, this is still fresh pyrite over here, which wasn't escaped the solution, etc. That pyrite gives rise to what's called efflorescence. That's this white material here. So that white material, efflorescence, is water soluble. So a stream running through here will pick this stuff up and will just contaminate the water like you will not believe. So there's a stream running off that dump. It's essentially from sulfide, from pyrite. And so one needs to mitigate this as well. It's interesting to note that many of these streams actually run into reed beds. And the reed beds have acted as filters, and they've actually filtered out a lot of these deleterious things. So by the time the water gets to the Vaal River, it's pretty pure. So these reed beds to the south of Johannesburg, the Rietspruit, for example, is the name of one of them, are pretty important. But of course, the other methods as well that are used to mitigate this acid mine drainage. The other thing is that gold has been left behind in all those dumps in early Johannesburg, with the highest grades being in the oldest dumps, which are to the north, because the extraction was not as good in the early days. And some of those dumps are running at about 0.5 gram to 1/4 gram of gold, which is an absolute bonanza on the surface. And then by the time you get to the bigger dumps, the younger dumps, you're getting about 1/4 gram of gold, which is still being mined, in fact, by this method of hydraulic mining. So these mine dumps are really being reworked again to extract the last amount of gold from them. And so CMR is an example of one of these mine dumps that has disappeared. And also the Park Central, which used to be a very big mine dump with a drive-in cinema on top. That's now gone, and that's all that you're left with over there. So at the moment then, iProps, which is the derivative company from Rand Mines, has reclaimed a lot of this land, and they're selling it off now. There used to be dumps in this area. So Johannesburg, the face of Johannesburg is changing dramatically with the dumps disappearing, and many malls, particularly Chinese malls, are developing along this area, huge developments where the dumps used to be. So that really is the story. It remains to say, well, what is the future really of this goldfield? And as I say, people are doing research on it. Various people are doing various kinds of research. Gillian, for example, is doing research. Lawrence Robb, all Wits people, about maybe finding, Spike McCarthy, about finding further extensions to this goldfield. And maybe the use of electronic devices, robotics, etc., to help in the mining of this gold at depth. All sorts of possibilities. So it's not yet dead, but Johannesburg has a life of its own now. So I think that's about the story that I wanted to put across. So thanks very much.
Thank you very much, Viljoen. Also, because this is why we are here.
Yeah,
This is just
that's why we're here.
Gold finding, otherwise,
yeah, wouldn't have been here.
Yeah, I want to ask any question from the audience. Oh, I see there is something in the chat. Let's see if there's a question, or if there is a question from the people.
Okay.
There are some. Thank you, please, Scott. Let's see if I can. Maybe I need you, Grant.
Are you able to hear me?
Yes, we can. Please, Scott, go ahead.
Oh, great, thanks. Yeah, that was a great talk. Thanks very much. Two questions. One is so it appears that the grade, well, does grade along in your experience, do you find that grade decreases along the pay shoots? Like, for example, near to Johannesburg, as you go along down dip towards the south, do you find grade decreasing along individual pay shoots? Like, are we seeing sedimentological, like the sedimentological effects, like, on the proximal side, there's maybe more gold, and as you get distal, there's less. And I guess the other question I had was just about the future. Like, do you think in terms of the future of the Wits, do you think the problems are more geological or more engineering focused?
Yeah, no, thanks for that. Very good questions. The first one is a very important question, and that is that the pay shoots don't necessarily follow the deepest part of the channel, the distributed channel. So you'll find that the gold concentrates on the side of the channel or in concave bars, etc. So a little bit away from the channel, but the actual channel gives you a clue as to more or less the direction to go, and then you'll find the actual richer gold, maybe in thinner reef, but away from the axis of the channel. So that's really important to bear in mind. So that's a very important point that you make there. So you've got to bear all these things in mind and understand the sedimentology a little bit better. What was the other question?
Oh, yeah, it was just like in terms of the future of the Wits, like essentially, do you think there are interesting geological observations that could be made to bring back life or to bring back some excitement to the Wits, or do you think the problems at this point are mostly on the engineering and like the geology has kind of been sorted and now with the problem is more on the engineering side?
Yeah, look, I think obviously engineering is going to play a pretty important part, particularly in the deeper levels. But geology is playing a huge part. For example, I think Spike McCarthy is doing a lot of work on a database of all the boreholes that have been drilled in the Wits. And he's modeled these, and he's come up with some very interesting ideas of possible extensions that one could look at using all our knowledge from the past. So I think there's pretty good scope here, both from a geological point of view and an engineering point of view. Obviously, you've got to work with the engineers and from the geophysical point of view as well. I think that's highly important. And some of the stuff that Ray has done, and also I think Sue and your people on the Wits, very important contributions made by geophysics as well. So you need to get a multidisciplinary approach to the Wits, where you're using all these various methods to understand distribution patterns, understand where you could find a new Goldfield. In fact, a lot of effort has gone into finding another Witwatersrand elsewhere on the planet. And mining companies have put a huge amount of effort into this. And the question is the Witwatersrand unique, or are there other possibilities? And I've looked at a whole lot of these. I've looked at conglomerates in Brazil, the Moeda, which has got gold, got uranium. So it looks like Wits. But has never really developed into a huge gold field. You've got the conglomerates in India, which are looking pretty interesting, also with gold and uranium. So that's quite interesting, the link between gold and uranium. So you do get these things. And of course, in Ghana, you've got the Tarkwa. So the Tarkwa conglomerates of Ghana are probably the closest link to the Wits in that they contain significant gold. And they are being mined on a fairly big scale in Ghana. But besides that, I know there's big exploration going on in Australia, and they're announcing all the time that they've discovered something. So they've got something that looks like the Ventersdorp contact reef, but I don't think they're using any kind of Witwatersrand model to really understand it. So they may well have something there in Australia, in the Pilbara area. Where else? There's something in China as well. Yeah, those are the main ones, I think.
Thank you, Richard.
Thank
Is there
you.
any other question? Otherwise, I thank very much our guest, Richard. I thank you for being here and following the talk. And I want to thank CCIC for the drinks and to see you next week for another alumni talk. Thank you very much.